the moon the other day. This actually is, if you read the caption, not drawn to scale because of kind of the lens that they used, but this is the continent of Australia. Whoa. There's the Earth. I know, it's because of the fisheye lens. This is actually a repair work. That kind of foil-looking thing is the Hubble Space Telescope. And this is, of course, we don't have any space shuttle missions now, but this is a space shuttle mission to go up and to repair the Hubble Space Telescope. Some things about the moon. One thing, synchronous rotation. And we'll be talking more about this, but this is my, well, let's see. Let's make this the Earth for now. This is the Earth. Okay. So how many days does it take the moon to go around the Earth one time?
365 days.
Nope. The moon to go around the Earth.
I don't know that. That's a good question.
It's on the slide.
Just 24 hours.
What's that?
29 days.
Yeah, 29 days.
Yeah,
this is the moon, this is the Earth. The moon goes around.
Oh, yeah, 30 days. Them things are like, because it's a month.
About a month, yeah, about a month. Yep. Very good. So we're going to make the sun over there, okay, somewhere. That could be like the monitor, okay? And if I am the Earth, wait, sorry, not the Earth is there. If I'm the moon, I brought some things here. Why do we see the moon? Does the moon glow? No. It's just because the sunlight reflects off the moon and we see it. So if this is the Earth, notice I wrote sunlit over here. So here's the sunlit portion. So there's the sun, the moon, and the Earth. So how much of what kind of moon is this? Full, yeah. It's all about counterclockwise. So I'm going to go over here like this. Now what kind of moon is that from the Earth? Half, yeah, we should call it quarter, it'd be last quarter, very good. I'm going to go over here. What kind of moon is this? New, perfect. And then over here, that's a half, another quarter, then we're back to full. So if you take about 30 days, if you round it down to 28, if you take 28 and divide it by 4, what do you get? 7, yep. 24 divided by 8. Wait, 24, no,
28 divided by 4.
28 divided by 4, thank you. 28 divided by 4. So you have a fourth here, a fourth here, a fourth of a circle. Fourth here, fourth here. So it takes about 7 days to do this. It takes about 7 days to do this, and about 7 days to do this, and about 7 days to do this.
So is February perfect then? Or?
Yeah, February is kind of a nice, yeah. There was exactly, 28, or it's a leap year, 29. Yeah. Now, this talks about synchronous rotation. I have a slide to come up and to kind of show you what that looks like. But just to remind you, can anybody read what that says?
Near side.
Near side, very good. What's it say?
Far side.
Far side. We count, which side is prettier, the near side or the far side?
The near.
The near, yeah, I think the near is. And here's the deal, and you guys hopefully convinced yourselves of this, that as the moon orbits the Earth, it has to spin a little bit. So it always has one side near it, and it completes one spin on its axis, one rotation, for the time it takes to go about the Earth one time, one orbit. So one rotation, okay? So one orbit is equal to one spin or one rotation. One orbit is equal to one spin or one rotation. That's what we call in sync. That's the synchronous rotation. That's why we only see the same side of the moon all the time. So, not switching gears, one of the things we talked about before is the distance between the sun and the Earth constant. No. Sometimes the Earth is closer to the sun, sometimes the Earth is farther from the sun. I mention that because we use a similar terms with the moon. So this is back to this is the sun, this is the Earth's orbit, or it could be any planet's orbit. Oh, it's a little, trying to make it more oval or eccentric. Okay, starts letter A. What do we call this? What do we call this point? Very good. Aphelion. What do we call this? Wait, no, you got me wrong, no. Sorry, we don't call it, I lied.
That's the P one.
That's the P one, sorry guys,
Perihelion.
set you up, perihelion. Goodness, I think I did that recently. Perihelion when it's close, and then what's this one, starts with letter A? The aphelion, thank you, yep.
I was gonna say, you said it starts with an A.
I know, I'm so bad, I'm sorry. So if I go ahead and make this Earth, okay, and I'm gonna make the moon orbit the Earth, okay, so this is the moon's orbit. Guess what? It kind of has a similar sort of deal. But we don't call it helion because, of course, the moon isn't orbiting the sun, the moon is orbiting the Earth. So we call this perigee, yeah, and we call this apogee. Okay? Perigee and apogee. Apogee. Goodness gracious, can't spell. We talked the other day about supermoons, okay? The thing about it is if you have a full moon at perigee, if it's full at perigee, that means it's super. Okay, that's how you get your supermoons. Because full moons are kind of striking, and if it's extra close, it's extra striking. Supermoon, perigee. Full moon. Okay. You get a mini moon if it's a full moon, but it's an apogee. I've heard of supermoons. I've never heard kind of in the news a mini moon, although it's a cute phrase. So over here, if you have a full moon at apogee, then it's a mini moon. Okay. All right. And I kind of mentioned this before that there's no, like, the reason stars shine is because they are creating energy in the energy. Stars shine because they create their own energy. But planets and moons, if the sun were to go out, they wouldn't glow at all. Okay, so the only reason we see it is because light from the sun is reflecting off it. So this is kind of what I talked about a little bit ago. Notice I added a few phases here. So kind of switching it up, we have the sun coming from this direction, and then of course the moon is orbiting the Earth in clockwise or counterclockwise? Counterclockwise, yep. So here we have 7 days apart, new first quarter, full third quarter or last quarter. But in between we have a few things. If it's just kind of, how do we say, if it's between, if you see a sliver or anything less than a quarter, it's called a crescent, like you eat the roll, a crescent roll. I'll look like a crescent roll to you. And if it's getting more and more illuminated, we call that process waxing. So between the new moon, which you don't see it at all, and between the first quarter, it's a waxing crescent. Yes?
Okay, so when you're looking at it at the sky, you don't have a diagram in front of you. How would you tell the difference between the waning and the waxing?
Good question. So here's the deal. If you hold out your right hand, whatever is on your right hand, if it's illuminated or if it's dark, it's going to kind of continue or sweep over to the left. So here in these diagrams, it will go from, we know it's waxing because it's illuminated on our right. Okay, so it's a crescent. It's going to keep getting brighter. We have first quarter. If it's past a quarter but not quite full, we call it a gibbous. And if it's getting more illuminated, we call it a waxing. Then we have full here. Now between full and over here, you told me that's the last quarter, okay? And actually the way this works is you would see it lit up right on this side is where you would see it lit up because the sun's over there, okay? So in that case, if you hold out your, this is kind of, the reason they have two here is because this is the perspective from looking at how it's orbiting the Earth, and this is how you would see it in the nighttime sky. Sorry about that, but that's just how it is. This last quarter, can you see if I put out my right hand, it's dark over here? So actually from right to left, it's getting more and more dark, which means it's getting less illuminated. So actually after full, you're going to see this sort of situation in which you see a waning because it's getting less bright, and a gibbous because it's between a full and a quarter. We see the third quarter here, and here we would see a waning crescent. So yeah, it's a little bit confusing because we have like 2 extra things here. These outer things are what you see it as, and the inner ones, of course, is trying to show you how it's going to orbit the sun, or orbit the Earth. So I have a few videos. We'll see if we like them. But for your test, you might actually have like pictures of the different phases of the moon, and I might ask you to connect up a name. So we'll see. Sometimes I do that. So this is all of the phases of the moon in the right order. So of course, new, we don't see it all. And then these until you get the first few, until you get to the full, these are all waxing. And then after the full, they are waning. So somehow get that under your belt. This actually, I'm not going to spend a whole lot of time here, but it's another figure from a different textbook where the gal is the moon, the gal is the Earth, and you can kind of see the moon going around her, and we actually have the sun is, in this case, up over here. And you can see what she sees as the moon orbits her, which she's the Earth. Waxing crescent, first quarter, waxing gibbous, full, waning gibbous, third quarter, and waning crescent. So like the video said, that terminator is, tomorrow night we'll kind of be focusing along the terminator because that's where the coolest parts are. I just thought this was cool, where this is different pictures of the moon low on the horizon, and they just have different, they have like, just very clever. This I'm not going to necessarily spend a lot of time on because it talks about the fact that the moon must rotate. Here we have a couple of options. We have option A and option B. Option B here is actually the real deal. You can see as the Earth, as the moon orbits the Earth, you can see it spinning on its axis. So we only see one side of it. Up here, if it didn't spin, okay, we'd actually see both sides of it, okay? Again, this is just to kind of reinforce the spinning and the orbiting take the same amount of time, so we call it synchronous rotation. Here, the gal here is the moon, and the little blue orb there is the Earth. Here she's not spinning at all, and here she's spinning exactly one time as she completes one orbit, sort of like what you guys did in the lab a couple weeks ago on Friday. Synchronous rotation. But I'm hoping that we're all on the same page. The whole near side, you guys told me the near side's prettiest. You know, it's got the mare. What's the far side's all pocked up, right? That this near side and far side is not the same thing as like the lit side and the dark side, because that's not true. The far side, for instance, if that's the Earth and the sun's over here, and of course this is the moon, the far side's entirely lit up, isn't it? We don't call the far side the dark side because at new moon it's entirely lit up. So those are things to kind of share with your friends. So 2 sides of the moon. This has got all the mare. What's the lighter area? Starts with letter H, I promise. Highlands. Yeah, the darker areas are the mare. The light areas are the highlands. And this is that kind of that. This would be the far side. Okay, so this is kind of the marked up side that we don't see. So here's the deal. How did we get these pictures of the far side, you think?
No,
Telescope?
that's not what I'm trying to say.
Well,
Space.
yeah, I'm thinking some sort of satellite that, or we actually have definitely did our fair share of orbiting the moon too. We can go around and do these pictures. I think it was the name of the movie was like Apollo 17 maybe. It's a sci-fi movie, totally sci-fi. But it was kind of interesting because in the far side was where the rock aliens
Was it
were.
13? Apollo 13?
Was it 13?
It was 13.
Oh,
I watched that movie. That was
I saw it in theaters.
weird.
Okay.
That movie was weird.
It was good.
Sci-fi. This actually is a photograph. You never know sometimes when you see something it's a photograph or just like photoshopped, but the sun is over here, and this would be the moon during its new phase, where we actually see the earth lit up by the sun and the back of the moon lit up by the sun. So this would be the far side of the moon. These are some pictures I took. So what do you think? Is this a quarter, crescent, or gibbous? It is totally crescent. I know it seems kind of on the bottom, but if you take the bottom and kind of go like this, do you think it's waxing or waning?
Waning.
How many people think it's waning? How many people think it's waxing? Why is it waxing?
Well, I wrote down that it's that way. From waxing.
Okay.
It's
Wait, which way is it? Is it going this way?
See,
or
if
this
you
way?
take this and kind of swing it up,
Yeah, wax.
yeah, it's waxing. So if you hold out your right hand and whatever I know it's kind of hard with this one. You hold out your right hand, this would be waxing. Yeah. Here's one for you. All right, so is this a quarter, gibbous, or crescent?
Gibbous.
It's a gibbous, yeah. And how many people think that this is waxing? How many people think this is waning? Me too. It's waning. Because this one's easier to see. You hold out your right hand.
So it's not.
I'm thinking gibbous.
There's space.
Waning gibbous. All right, so is this a crescent, gibbous, or full?
I think
It's
I could say
It's not
gibbous.
all the way full yet.
Yeah, it's gibbous, almost full. I'm kind of thinking this still needs to fill out. So if I kind of go ahead and rotate that now down a little bit, how many people think that this is waxing? How many people think this is? I'm going to go ahead and take that dark area and kind of bring it down. So I'm going to kind of do it like that. How many people think it's waning? Yeah, I do too. Now, one of the topics I want to talk about is Earthshine. I don't know if you guys can see that. It's like a ghosty part of the moon. You're like, Earthshine on the moon? I'm going to show you this video. But you kind of see this. So this actually, Earthshine is specific for crescent moons. So you wouldn't see this with a quarter or a gibbous. So assuming that this is non-illuminated, are we looking at a gibbous or a crescent or a full? Crescent, I'm like a crescent. And kind of like we did before, it's kind of swing this up. Is this waxing or waning?
waxing.
It's waxing, yeah, it's kind of swing it up. So let's see what this video does, Earthshine. It's kind of a cool phenomenon. And again, it only works with crescents. Camera, one thing you can, I don't know that much about cameras, but you can change the exposure time. So if you kind of make it a little bit longer exposure time, that's when you're going to kind of see that ghosty bit called Earthshine. This topic of tides has been in the news with Hurricane Florence. They actually were more concerned at high tide about the ocean water that was going to be drugged onto shore. So you may or may not know that about this whole thing. The tides are caused by the presence of the moon. And it really works like this. Basically, you're looking down at the North Pole. You see the Earth spinning on its axis by the red line. Here's the moon. The moon is going to orbit the Earth, but it takes about 7 days to get from here to over here. So in a given period of 24 hours, as the Earth spins, it's kind of constant a little bit. Newton said that there's this whole thing about gravity, and so actually tides are just due to the gravitational interaction between the moon and not the Earth per se, but kind of the Earth's sloshy liquids. Okay, sloshy liquids meaning large bodies of water. Air is actually, I would say liquid, but air is a fluid. So the two fluids, the Earth's atmosphere kind of bulges out. Okay, and so does the large bodies of water kind of pull. I think I got time. I'll show you this video about tides. But before I show you the video, do you guys buy this? And actually, again, in the news they were talking about it. Tides happen every 12 hours. This video will try to explain why we have a bulge here, and opposite that bulge, on the opposite side of the moon, we also have a bulge. So you figure the Earth spins once every 24 hours. So here it has a bulge. 12 hours later, it'll be over here. It has a bulge. So every 12 hours, we're going to have high tide. So to have like folks in New England area on our northeast get hit so bad, but Hurricane Sandy was so bad because it was a supermoon at so it was at perigee, and it made the extra high tides. So it looks like this. So Hurricane Sandy happened when it was I think it must have been a full moon maybe. So the moon and the sun actually pull and make the tides extra high. Like the video said, that's what we call spring tide. Neap tide looks like this, where those would be our quarters, where the video said that the sun is like half of the influence of the moon, but they're at right angles. The sun and the moon are at right angles, and that gives a kind of a lower tide than usual. It's called neap tide. So what does high tide and low tide look like? This would be, there's all sorts of cool pictures out there. This would be low tide. Oh, sorry, that would be high tide, and this would be low tide. See where these are actually, the water has recessed from the coast at low tide. So I kind of finish up with this, eclipses, and I kind of feel like we've talked a little bit about this. One of the videos we watched already talked about this. So just off the top of your back, top of your head, sorry, top of your back. Your choices are, let me grab the moon here, okay. Your choices are, stem left portion, new moon or full moon. Which one is possible for the sun's over there? Which one's possible for the sun to be blocked out? New moon or new moon? Yeah, new moon. So yeah, if it happens just right, so that the moon, as it orbits the Earth, passes in front of the disk of the sun, we get a solar eclipse. Yep. And over here, actually, I think the video talked about the moon going in front or going through the Earth's shadow. Here's the deal. If the sun's over here, here's the Earth that kind of casts a shadow. So if the moon goes into, just lines up just right with the Earth's shadow, a full moon will go blank. Okay, it's kind of sometimes called the blood red moon. Okay, and that's what we call a lunar eclipse. So I've got some videos out there about that. So that's one of the things, I'm sure you have a homework question talking about that. This kind of talks you through, this would be, here we have the sun, this is the Earth, and these are regions of the Earth's shadow being cast into outer space. And here we see the, this one is a solar eclipse where the moon, at near new moon phase, the disk of the moon will block out the disk of the sun because of kind of their proximity, and we'll see the sun blocked out. That's a solar eclipse. Picture of a solar eclipse with a fancy camera to kind of see, when we talked about the sun here in a little bit, we're going to be talking about the different layers of the sun's atmosphere. Corona is one of the layers. This is back to a lunar eclipse where we have actually a moon that's in its full phase, and here you see it passing into the Earth's shadow. Lunar eclipse. There are different types of lunar eclipses. We have the total lunar eclipse, or we have the partial lunar eclipse where a bite is taken out. The most boring one is the penumbral lunar eclipse, where it just goes through kind of the wimpy part of the Earth's shadow. The video kind of talked about the reason that it doesn't line up just perfectly to give us a solar eclipse here at new moon and a lunar eclipse here at full moon. Has to do with the fact that the moon, as it orbits the Earth, actually, it's not in the plane of the ecliptic, being shown here. This blue sheet right here is the sheet that holds the orbit of the moon, and it's tilted outside the plane of the ecliptic. This actually, how many people saw the lunar eclipse this past fall? Yeah. So you could actually see part of it from our area. This though is showing you, the next one coming up for our area is 2024, which you'll have to go south a little bit, but we're planning on it. My husband and I are. But you can kind of see the paths that these solar eclipses take across North America. This, it's funny because this was from when I taught this class last spring, but it's still legit this fall. Actually, 2019, yeah. So you can see these are lunar eclipses, upcoming lunar eclipses. All right, well, very good. So we got through part 6. So this homework will be due, we'll meet again on Wednesday. And on Wednesday, I think we're going to probably knock out the moon with part 7. On Wednesday, we'll see if we have time left over to go kind of finish
Back and
Newton's
forward.
laws. What's that?
Back and forward.
Back and forth. Yep. Never a dull moment. Yes, ma'am.
Do you think the moon is partly responsible for how detrimental the red tide is going? Kind of the acceleration of it? I know it's not necessarily.
The tides. I think if we didn't have tides, talking about the algae bloom.
Yeah.
Yeah, if we didn't have tides, the algae bloom would probably not be ready. So doesn't the red,
I'm a
the red
So-
tide,
It's just been accelerating basically. Like
That's it.
not moving.
I would think it's warm water.
Seemed like I'm doing classes.
Sea surface temperatures. But